Start recording. All right, so Assalamu alaikum, Brother Wasam. Go ahead, man. We are all excited to watch your blockchain stuff. This is very interesting.
Well, I must say, I mean, I'm more excited to actually watch the cool work which you guys are working on.
All
I
right.
mean, this is great, Naeem, by that you're like leading like our or like I mean young gen over here. I mean, like leading from the like front and kind of like showing them ways that how they can use their like software development expertise to work early on. So I think I mean this is awesome.
I know. This is
So
a real deal. This is not, like I said, this is not a training or anything. This is a real project, and we are running it like a real project. Even though there are some hiccups, sometimes people get busy, but we are thriving to be real. I mean, not really just going talking about stuff.
and that's what exactly makes it more exciting and energetic actually.
Yeah.
Right? That there are like I mean like our like mountain house community over here is building out like real products. I mean putting them to like real tests, right? I mean I saw you guys are I mean I didn't see the like whole like demo in the screens, but I realized that you guys are working on like something which kind of like help manage the MHMA operations. I think so. I mean this is just like awesome over here. Yeah.
Yeah, we
All
are
right.
planning to demo it in one of this MHMA
Family nights.
get-togethers. Yeah, family nights. So we will see.
Mhm.
Hopefully, we'll get there and we'll be showing to the community what we have been doing. Yeah.
Exciting stuff. Exciting stuff. Yeah. Okay, perfect. Let me know if you guys can see my screen.
Yeah, we do see your screens. Can you? You haven't put in the presentation mode yet. Okay.
I haven't. No.
Okay.
Works now.
Yep.
All righty. So, by the way, you guys can see which screen. Do you see both? No, I actually made sure I just share the big one screen. Okay. Alrighty. Okay. So, last week when we started, right? If you guys like remember, I kind of like the like subject of this particular slide read as next 30 minutes, but going through the like last section, I kind of like realized that look, I mean, this is a topic which needs a lot of time, has kind of like a lot of like subtopics within it, right?
Yeah.
So I have just for a little bit of like humor sake, we have like kind of like updated to like next 300 plus minutes, and I will not be surprised that it ultimately does takes us this much time. These are really exciting topics. You kind of like get into a kind of like into a like a funnel with a kind of like a lot of like fancy keywords and methodologies, and you do want to touch upon most of them just so that like you can make the like complete sense of this whole blockchain beast which we're dealing with over here.
Yeah.
So without further ado, I want to set a little bit of context for like today's meeting. I know that last time when we were talking, we pretty much like talked about the like first section of blockchain, and as next section was really talking about cryptocurrencies and NFTs. But I want to go back. I want to actually stay within the blockchain section and talk about two very important things called smart contracts, and also rehash the like topic of various applications of blockchain. Last time, like I myself actually went back and listened to the recording of the like first presentation, and I realized that you know what, nobody would be excited about using blockchain and adopting to the whole tech ecosystem unless you really understand that where and how you want to use it. So I think that's something I would like to spend a little bit of time today. I have a few verbal slides, but I will try to like talk through them and present you guys some examples, right? Which I hope like maintain the interest. And at the same time, I don't want to like keep on dragging it for over an hour. I think so. We are just going to time box it by like 9:30, and hopefully call for another session where we can pick back on where we leave today's session. Anybody, that sounds like a plan?
I think so. I think that's what we are looking for. And thank you for going back to these two important topics. I was looking forward to these things.
Yeah, no. I mean, in fact, like thanks for your like guidance. I mean, when we met on Friday, right, where you like mentioned to me that smart contracts is one topic, right? We would like to go in a little bit of like depth, and I 100% agree with you on that. That yes, I mean, I should talk about it because the whole paradigm shift of a non-blockchain to like blockchain is like a smart contract is at the center of it, right? A smart contracts are the one which is really influencing that change, right? So let's quickly jump into our presentation. I just want to like summarize that like in a very short like sentence, that at the core of like a blockchain, right, these like blockchain concepts are really like three core pillars, right? Decentralization, transparency, and immutability of any data which you create, right? So like these are really the like three cores: decentralization, transparency, and immutability. Okay, now let's touch base on what we saw last time, right? Just very quick, a few seconds, that we talked about that what is blockchain, right? We talked about its core characteristics, like indelible, data once created cannot be deleted, globally readable, can be read by anybody who wants to participate as a node on the blockchain, right? Rule-based rights is smart contracts over here, right? So we are gonna talk about this in a bit, and all the actions which you take on the blockchain are strictly ordered, okay? And we talked about an example over here that how in a central vote registry system, right, which is trying to like pick the like top like favorite foods, right, under like Desi cuisine, right? So we kind of like saw that like users are posting their transactions. I mean, they're like choices, right? They're like choices which they're posting from the apps to the like backend, right? That's what I'm calling a transaction. Okay. And if we like time box it, that okay, I mean at T2, what is the like verdict, right? We can see that down in the database over here, right, transactions were really maintained in T1, T3, and T2, right? So they're like order, right, is kind of like marked by the central system, right? So many times you cannot just fully trust this central system, right? Something might have gone wrong, and which changes the core outcome of that operation, right? And I showed you guys over here that how this whole world of centralized system becomes decentralized, where now there are like various nodes, quote unquote, like various processors on the whole network, right, which accept your data, right, and process your data and register it into a central report, like register it into a globally distributed repository, right, where anybody, right, like from over here on the right hand side, you can see that these are the viewers of this data, right? Anybody anytime can view this data, and they will see data in its right order, right? So so that's a little example I kind of like walked you guys through. And I also talked about that really, I mean, at the core of a like a blockchain, right, I mean, talking about in terms of the like data structure, right, blockchain is really just a sequence of blocks, right, where every block knows what's the every block has a reference to the previous block, right? It really doesn't know what the block contains, but it just has a reference to the previous block, right? I have intentionally not got into the details of what really this block looks like, right? I mean, what is the data structure behind a block? But I just want to mention one keyword, right? Kind of like put it out there as food for like thought, to kind of like a like another like keyword, another interesting topic for you guys to like search and learn. There is a data structure called the Merkle tree, right? So I kind of like realized last time when I talked about this whole data structure, I didn't mention about Merkle tree. Well, Merkle tree is one thing which I will encourage you guys to go and read up. I'm not going to talk about it in depth over here, but that's one of my like favorite data structures, right? Where how you can use the power of a tree kind of like data structure in making sure that the node always tells you that what underlines this whole like tree. Okay. So read about it. That's a pretty fun thing. Second, we talked about some core, we just revisited the core characteristics, and I kind of like mentioned some core tools, right? Tools and keywords, which I want you guys to remember on your journey of a blockchain, right? MetaMask, right? That's your own like personal wallet, right? You need a wallet to integrate with a blockchain, right? You call it a wallet just because of the like sensitivity of the data which is stores, right? Which is really a private key with which you integrate, right? I mean, I won't say it's like private key, sorry. I will just say a set of sensitive keys, right, which you use to integrate with the blockchain. Okay, so that's MetaMask over here, right? Then we talked about Web3, we talked about Get, right? And we talked about that what the whole like Ethereum ecosystem is, right? Where you have like smart contracts running within the Ethereum ecosystem, right? You have nodes, right? Some of the like nodes are just information nodes. Some of the nodes are just some of the like nodes are in the business of verifying and mining, right? I'm also not going to get into the concept of mining over here. That kind of like needs its own 300 plus minutes over there, right? But different kind of nodes. And then at the same time, there are entities which are oracles. Oracles are kind of like central storages of the whole blockchain data. Many times, like going back to this picture over here, I showed you guys that today over here, there's a central, in a centralized system, right? There's a central database, right? So like this entity over here, right, manages, owns this database, right? They incur all the costs of maintaining it, right? But now when you map the central system onto a blockchain, right, every node which is participating on the blockchain, regardless in whatever capacity, as a verifier, as a miner, as just a node which accepts this information and broadcasts it to the larger network, right? In whatever capacity, everybody brings their own database, right? So you're also going to hear that many people describe blockchain as nothing but a global decentralized database, right? So like that's another way to like describe blockchain. So with everybody maintaining their like database, right? We don't want that everybody is bearing the same high cost of maintaining this centralized database, right? So many times these nodes offload most of their data out to entities like oracles that, hey, you go ahead and maintain this data. This data is just so redundant, everybody has it, right? So instead of everybody keeping a copy of it, you just push one copy, right, to these oracles, and these oracles maintain that data for the life of that blockchain. So so these are some like key concepts which we highlighted, right? Taking it to the next step, right? Let's zoom into this concept of smart contracts. Okay. Now, what exactly is a smart contract, right? So I kind of like just went around, I mean, did some like little bit of research and put my own like keywords over here, right? With which I wanted to explain you guys the concept of a smart contract, right? It is a concept of a self-executing unit of work, okay? And I'm just gonna stop over here for 1 minute, right? You guys just showcased that you guys are building a kind of like a system for MHMA, right? For like managing the operations, right? You have APIs, the bit of data which you pass to those APIs through post, put, get, like through post and put APIs, right? That data, quote unquote, is a transaction, okay? Now that transaction is managed by the central server, right? By the central code, the JavaScript code which you guys are writing, right? Who owns that code? You guys. Who makes sure that this code executes the like right way? You guys, the logic which you are coding in over there, right? Do you have the control in going in there and changing the data which anybody is creating? Of course you do, right? Because you own the whole system, right? You are not going to broadcast this data to everybody and tell that, hey, am I doing the right thing? No, you just feel like going in and changing the data, you can absolutely do that, right? So so that's how these central systems work, these centralized systems work today, right? Of course you cannot, I mean, in like many professional industrial grade systems, you cannot just go in and change data right down in a database or through some other like application connected to like this data. There are various triggers, there are various controls, there are various regulations around it, right? It's easier said than done, right? But just for discussion explanation sake, right, just think about it, that you can go and kind of like mock the data which you have managed through a central system, right? So coming back to like this line over here, right? A concept of self-executing a transaction, a unit of work, right? Not by this one central system, right? Which you guys are building and running, but by a trusted network of computers, right? So any unit of work which you are creating will not be executed in one place. It will be executed across the whole network, right? Every node on the blockchain which executes this unit of work is called a miner, right? So they are going to take this unit of work, right, which is the data which you put in your post API, and send it to the like whole like network. I mean, you actually send it to one node, right? And the node broadcasts to the whole network and tells that, hey, look, this data should be matched against this code, right? Now, what is that code? That code is the smart contract, okay? So yeah, so like that code is the like smart contract, right? The whole concept of smart contract was really introduced by like Ethereum. I mean, Ethereum was the first one to really come up with, right? The first commercial blockchain which came out was the Bitcoin network, right? But right after that, I mean, I won't say like right after that, there are quite a few years in between, and a lot of other like blockchain projects were kind of like work in progress. But the next big commercial blockchain project which really came out was Ethereum, right? So Ethereum pioneered the whole concept. I won't say like pioneer, sorry. Ethereum commercialized the concept of smart contracts, right? Where you write code, right? Just like how you write your JavaScript code, but instead of running it on one central computer, you run it on a sequence of computers throughout the network. Every node executes that data, right? I mean, it means performs that operation, right? And then solves a problem against that particular data, right? Like I will give you an example, right? A right example would be that uh, let's say that there was an API to create an activity, right? That there's a volunteer in the community, and that volunteer is going to go and perform an activity in the for the MHMA program, let's say, right? I mean, there's a family night program going on, and some volunteer has to perform some activity. So you go in and you register your activity through a post API, right? Your like post API request is broadcasted to the whole network. The whole network means all the like nodes on the network, they all execute that operation, right? The outcome is that, sure, go and register this activity in the database, right? The outcome is that now you have to register, you have to create a row in the database, right? Just think about it, something like that, right? Every node which got to that conclusion, as second step, is now going to solve another problem, right? And that problem is that it has a mining algorithm that, hey, you got to the final data, but now let's make sure that you were working on the latest set of data. The data which you worked on wasn't tempered, right? And the outcome which you got, it's exactly the same which others got, right? So to prove that, right, you solve another mathematical problem, right? So let's say if there are 10 nodes, all 10 of them, after processing the data, are solving this mathematical problem now, right? And the first one to solve this problem turns around and broadcasts the result to the whole network again, that, hey, I solved it, right? I solved it, right? Can you look at it and confirm that if I solved it correctly, right? And every node looks at that and says, oh, okay, perfect. You kind of like solved it, right? Looks good, right? If you get majority people confirming that, yes, you solved it correctly, then you are the winner, you are the miner, okay? And you will be rewarded for it, and you will be rewarded in the form of cryptocurrency. Sorry, I kind of like jumped a concept over here, but I just wanted to put it out there that what is the whole function of a smart contract? The function of a smart contract, it starts from the time you take this input, right? And you process it, right? And after, so actually, sorry, I think explain it this way. A smart contract is really the entry point to give actionable data to the whole blockchain. Okay. I think I'm just going to stop on that. I'm not going to keep going deep and explaining you that what happens behind it. It just gets so deep about it. So sorry about that.
So is everything with us right now? I mean, is there any confusion about smart contract? The example which Basam has given us, you guys understand about the smart contract? Or if there are questions, you guys should ask now.
Yeah, feel free to ask questions. Stop me anytime. Right? Questions are important. It kind of like builds the whole sequence of understanding with everybody. So go ahead.
I do have a question, if that's okay. And if it's a basic one, I do apologize. But I'm trying to think of this. I mean, I don't know much about this stuff, so I'm trying to think about this abstractly. on your PowerPoint, it says that smart contract replaces the middleman.
Oh, yeah.
Could you just elaborate, or if you've already said it, reiterate what that middleman is, and if there was not a smart contract, what that system would look like?
I was actually about to get onto that topic, right? And I first wanted to keep it to these two points, right? And before I get out of this slide, I want to kind of like summarize by saying that what really the smart contract is doing, right? Just to give you an example, right? Let's go back to the MHMA communities like program going on, and this central system tracking all the operations and the volunteer work and everything, right? So let's go back to this example that this is the central system, right? A volunteer registered their activity, right? It is now sitting in this system, right? Let's say that now there is an app, right, which Naeem Bhai has in his hand, right, which wants to know that, hey, what are all the actions which are taking place? I mean, which volunteer is working on what, right? It's kind of like a central like blotter screen where he's looking at who's working on what, right? Now, to retrieve data, right, on this particular app, I know it's pretty straightforward. You can just simply kind of like code a few get APIs, again going into the central system, right, and then reading this like data, right? Now let's plot this experience in a much more bigger scope, okay? That let's say you are system A, right? You track all the activities which people are performing, right? Now you're going to turn around and you're going to forward this data to system B, right? Now let's say system B works in a very different governance, okay? Somebody else manages system B, okay? Like just to give you an example, right, of activities again, right? That there are volunteers who are working on activities, right? Now you hand over this data to system B, which is now responsible for making sure that, hey, for all these activities which people are performing, are these compliant activities? Means that, hey, are they following all the like right codes of performing that activity, right? I mean, are they taking all the like precautions in doing those like activities, right? That's system B, right? Now system B, right, after looking at this data, right, says that yes, no, right? So like some activities will be rejected, some activities will be confirmed, right? Now, for going back to the app which Naeem Bhai has in his hand, right? He wants to look at, all right, what are all the activities? And he also wants to like look at, okay, let's just make sure that, hey, for all the activities which they're performing, are these compliant activities, right? As per certain rules, right? And all these like compliance of rules sits with a very different organization, let's say, right? So what is Naeem Bhai gonna do? Naeem Bhai now has to code to integrate with this other system, right? And pretty much retrieve data, right, against all those activities, right? So what it does is, right, that it kind of like increases the scope of work, right, for like Naeem Bhai to like just gather this data, right? Just because that we have this like middleman in the like between, right? Which is what this guy is only doing is just injecting a yes or a no based on looking at certain regulations, right? That if somebody is performing that activity correctly, right?
Yep.
So what blockchain really brings is that it kind of like connects the concerned parties, right? Which is what is Naeem Bhai, one is the like volunteer, and then there are a set of rules, right? So it connects, right, all these parties together under the banner of a smart contract. So the smart contract has all these rules and everything coded into it, right? You just trigger one action. So I mean, you just like submit a request that, hey, I am about to do this activity, right? And that's it. The smart contract has all the logic, right, to validate that, hey, if you are doing a compliant activity or not, right? And like, again, I mean, the counter argument can be that, hey, yeah, then you can pretty much go to that company B and figure out everything what they're doing and code it in your central system, right? I mean, that's the counter argument, right? But if you do that, right, then you are doing multiple things. You're replicating work, you're increasing work, right? You're kind of like increasing the entire scope of your own system, right? Which becomes less manageable, which becomes difficult to like manage, right? And then at the same time, you guys are not those smart people to confirm, to say that, hey, yes, this, whatever you are doing is the compliant activity. But instead, if it goes to a smart contract, then you're going to link all the parties, right? To like say that, yes, you are doing the right thing at the smart contract layer. So like, that's what I really mean. I mean, it has a much more like deeper concept, right? But that's what it really means, that the power of a smart contract is that it really kind of like removes the like middle layers, right? In like between any operations. Like in my last presentation, I gave you guys an example of supply chain, and I'm going to touch base upon that when we get to the like next slides. So over there, I can show you that how the power of smart contracts and blockchains together are kind of like removing middleman, right, from the whole ecosystem. I hope I was able to answer your question.
Yes, that helped a lot. Thank you very much.
Okay,
that was good. Yeah, awesome. Yeah.
Cool. Yeah, I'll try my best to, man, keep it at a level which resonates better with you guys. I'm sorry. I mean, sometimes I like to get into like deeper details. The whole domain is so thick that
I know.
unless you get into the like details of it, it's just difficult to understand it yourself even sometimes. Forget about it.
Yeah, I mean, I think you're doing a good balance of it. Let's keep going. Yeah.
Okay, cool. So I want to show you guys what a smart contract looks like, okay? And for like that purpose, let's go here. I am going to show you guys my, ooh, where did it go? I actually had a remix. All right, so let me know if you guys can see my screen.
Yes.
All righty. So so in our presentation over here, right? Let's go over here. We have an example of a vote registry system, right? A balloting system, okay? And I have a smart contract explaining that how this balloting system behind the scene really works, okay? That when we map the central system, right, into a decentralized system, right, then what does it look like, okay? So I'm going to keep this screen on, and I'm going to keep switching between these screens. Of course, I mean, they don't have the like direct relevance, but the concepts are there, right? So first of all, right, the whole sequence of events is that first you write a smart contract. Your smart contract is really the code, right? And once your smart contract is written, right, you pretty much like go to this IDE over here, right? Just like I don't know what IDE you guys are working on, but let's just pick on IntelliJ, right? That if you're working on IntelliJ is an IDE for like writing code in various programming languages, right?
Yeah,
so
we are using
here,
VS Code. Yeah, so it's similar.
Okay.
Yeah.
All right, perfect. Yeah. So like back in like VS Code, right? You kind of like have a whole project structure, right? You kind of like define your class files and all clubbed under a project, and then you compile the project, right? And once you compile it, then it kind of like runs within a service container, and your service is running, right? So similar concept over here, right? That you define your workspace. In your workspace, you define your contracts, right? So over here, I have some sample contracts, which I'm going to walk you guys through, right? And I saw that you guys were doing JavaScript programming. So smart contracts are written in various programming languages across different blockchains, right? In our example, we're only talking about Ethereum and Solidity. So Solidity is the native programming language on Ethereum. Okay, so the like syntax is very close to like writing like JavaScript code, right? So let's jump into it, right? So you can see that this is a contract, right? I mean, the contract keyword really defines the scope of the like whole smart contract, right? And you can just see that this is the whole smart contract, right? Over here, we are creating two different structs, right? So structs is nothing but a data structure, right? Kind of like a class file you're creating, right? Which holds onto specific data, right? So you can see that what is the voter, right? So like weight is more like, I mean, this is an example which I pulled over the like internet, right? So like weight is more, I mean, if you're defining something like fuzzy, right? Voted I mean, what is the like status of this particular voter, right? If voted or not, right? And again, I mean, ignore the whole concept of delegate, please. I mean, this is more like that a voter can delegate, right? Somebody else to go and vote on their behalf, right? That's the concept explained in this particular smart contract. I was thinking about taking it out, but I wanted to just leave it there, right? Just to show you guys that so many things can be done under a smart contract, right? And then of course, I mean, vote, right? That what vote they have casted, okay? So this is a voter, right? And then proposal, right, is what are they voting for, right? Going back to our example, we were talking about like biryani and nihari, right? So again, the proposals are really biryani and nihari, right? And who are the like voters? The voters are really user one, user two, user three, okay? So, and then, I mean, it has a fancy concept of a chairperson, right? So the entity who deploys the smart contract to the blockchain owns the smart contract. Okay, I mean, they have the supreme authority to like manage to go back and update the smart contract, right? To pull down the like the smart contract from the like blockchain, right? So, and they have like all the access to all the data with this smart, like, I mean, access to like data is already there, right? But again, I mean, data on a blockchain goes through various levels, right? So like this main person who deploys the smart contract has a special permission to like look at the data right when it is created on, I mean, right when it is created on the node. Okay. You got mapping, right? I mean, mapping is just like the like map data structure which we have in any of the other programming languages, right? So like this is really just kind of like maintaining a registry of all the voters, right? And then proposals, right? As you can see, it's an array list over here, right? Which is kind of like saving all the like proposals, right? Then now let's, I mean, this is a basic constructor, right? Just like with every other class file, you have a constructor, right? Which initializes the class with various basic parameters it needs to like function. Same thing over here, that if you look at the body, right, it has the proposal names, right? So when this smart contract gets initialized, you have to tell the smart contract, hey, what is it you are collecting votes on, right? So it kind of like a list of proposals are going to be provided to the smart contract at deployment time, right? So if I go over here, right, I don't again, I mean, I don't have a version of Ethereum running on my local machine over here on this one, right? But if Ethereum was running, right, then like like there would have been actually an option for me to load a smart contract which I want to deploy, and then right under that, somewhere over here in this section of this of the browser, it will show you a prompt, enter all the proposals you want to deploy with. Okay, so like that's the basic constructor, right? Then give right to vote, right? Very straightforward. This really means that register all the voters, right? So you can see that there is a voter, right, who kind of like invokes this particular method and says that, hey, I want to register for voting, right? So you can see that again, I mean, if it is a chairperson can give like, I mean, I can ignore this particular line, but just look at this one over here. That, by the way, require keyword in the world of smart contract solidity is literally like an if-else condition, right? This is really just like an if condition, right? That, hey, if this condition is met, is like successful, then your code keeps executing, right, to the next line. Else, right, if it fails, then it throws back an exception, right, to the EVM, which is the Ethereum virtual machine, right? And an Ethereum virtual machine raises an exception and kind of like alerts all the right people who are monitoring that particular smart contract, right? In this particular case, it is more like that it is going to go back as a response to the caller, okay? And of course, like register an error, right? So yeah, I mean, if it fails, then you get back this particular error message that, hey, the voter already voted, right? Actually, the voter already voted doesn't. Oh yeah, it is voted. Sorry. Yeah, if it could have been even like this over here, right? That if this guy water, right, water, right, is not null or something. Okay, so like what this would really mean is that, hey, is this water already registered, right, in the system, right? It could have been something like that over here as well. Okay, so I'm not gonna muck with it right now, but I'm just gonna comment it out, right, just to show you guys, right? Then moving on, that this is really just giving the right to vote, right? And then delegate. Again, I'm not gonna get into the groove of this. This is just this particular smart contract has kind of like a fancy feature of asking somebody else to go and vote on your behalf, right? Let's talk about this method, the vote function, the real function, right? So pretty straightforward, right? There is a proposal, right? Anybody who calls this, right, is the message sender, right? You first look up that this guy is there in the voter registry. If yes, then this whole sender kind of like variable is populated, right? And then you can see that, hey, I mean, if the like weight was 0, then has no right to vote, right? If the like sender is already there, right, with this not condition, then hey, already voted, right? If both these conditions are like true, just continue moving on, right? Then you can see that you just like cast the vote that, hey, voted is equal to true, and whatever proposal, whatever option they're voting for, that's set in the vote property, and that's pretty much it, right? And then of course, I mean, there's this other vote counter, right? So based on the proposal, right, you just keep on increasing the like vote counter that, hey, this particular item has been voted this many times, right? So you can see the like sender weight and everything over here, right? So this is the core function, right? Everybody who's casting their votes over here, right? Everybody who's casting their votes is actually invoking the vote method on the smart contract, right? By the way, in this little picture over here, this little like icon you see over here of like notes, right? This is really the smart contract, okay, which I'm showcasing. Okay. So going back, right, then let's say that there are these entities over here, right, who want to like know in real time, okay, who's winning, right? I mean, what does the standing tables look like, right? So they are continuously calling this function winning proposal, right? So like this guy is returning back the data, right? That hey, like, I mean, this is the particular proposal which is winning, okay? So so like this is that, right? And again, I mean, you see this little for loop over here. Why? Because there are multiple proposals, right? So just looking at the status for each proposal, right? And once you get that winning proposal, right, you just want to call in and see, okay, fine, who won, right? I mean, this again is a proposal, right? So over here it is giving you maybe the identifiers of those proposals. I mean, I don't know exactly what winning proposal variable was. One second, let's just make sure and see that. Actually, it doesn't matter this thing. It all depends upon, yeah. Oh, sorry, yeah. So it just gives you a vote count. Oh, okay, interesting. Yeah, this is not a complete enough response in my opinion. I would rather give the vote count and the winner name in the same response object, right? But you can see that they have another fancy method over here of, okay, let's just go and see that who exactly is that winner. Okay, so you can see that they call the winner proposal method internally, right? They get back the like proposal identifier. Against the proposal identifier, there's a name, and that's pretty much it, right? So in short, really, these entities over here are really just calling not the winning proposal, but they're calling the winner name method. Okay, so I think that's pretty straightforward, right? There is just I mean, there is a little bit of like learning curve in the way how you author your smart contracts, right? Because sometimes, like I'll give you an example that just like when you're writing your JavaScript code, right, you want to import certain libraries, right? So you pretty much have the same concept over here that you can see Spragma, Solidity, and you want the versions which are greater than 0.7 and less than 0.9, right? I mean, that's the like versions which you're importing, right? So like this brings in all the like Solidity libraries. If there was another like open source library which you want to kind of like include in your project, then you pretty much like define it the same way, right? So you got that concept, right? Similarly, if you want to like jump across different, like you want to reference other like kind of like Solidity class files or contracts, right? So similarly, you can define them along it and you can reference them, right? So pretty much the like the general pattern of authoring is like smart contracts is same as to like authoring any other JavaScript project or Java project or any other like Golang project, right?
No, this is
So
really very helpful because this tells us and all these kids also that it's like very similar to what we write in our JavaScript programs. It's nothing special. There is no magic here. It's same. It's a logic. Even it's a smart contract, but it still is a logic which, like you mentioned, removes the middleman and makes it more automated, right?
Yep. I think the core learning curves really come from the time when you go here and say that, okay, now I want to deploy this smart contract, right? And frankly speaking, after that, it all depends upon your role, right, in the ecosystem. Are you a person who is managing the deployments and the health of these like smart contracts, or are you a developer sitting down there and authoring these smart contracts, right? A little bit of like different responsibilities between these two different roles, right? So but again, I mean, I'm a big fan of always learning that whatever I'm working on, how will this be ultimately used? Okay, so
There's a question in the chat. Does Solidity have its own database or it works with the other standard databases?
Solidity, well, I mean, again, Solidity itself doesn't have a database, right? It is Ethereum which has its own database, right? So Ethereum maintains database files on your local on the like node, right? Whichever node accepts this data, right? They maintain like its own local file, right? Um, if I remember right, I
So what
mean,
you mean is there is no central databases here.
oh
Every
yeah.
node is maintaining their own files, and so everyone is responsible for their own stuff. There is no central database that many people are changing that stuff.
Exactly. You don't have this big database anymore. You have these mini databases which every node is maintaining, right?
Okay, got it.
Yeah. Okay, let's that said, let's quickly go back. I know we are at time. Anybody have time?
Yeah, let's give another few minutes. I would like to
Okay.
cover a little bit of the real world use cases, if you can.
Perfect.
Are you done with the smart contracts, or still have more to cover?
Just one more concept I want to call out.
Uh-huh.
In your programming languages, right, you have this concept of interfaces, right?
Yeah.
So what exactly are interfaces? Interfaces are, right, a set of functions, right? You just like define and say that, hey, any entity who wants to work, look, and feel, right, similar, right, should actually implement this particular interface. Okay, so Solidity has a similar concept, right? It has interfaces, right? Now these interfaces, right, are kind of like, I mean, they are not like as randomly defined as we do in Java or Golang, right? Or like, I mean, JavaScript, right? They follow actually certain standards. So Ethereum, right, has this concept. I mean, they have a central reviewing kind of like a authority, right, to whom you have to submit some industry standard interfaces. Like I want to say that, hey, I want to define an industry standard interface, means that anybody who wants to create a coin, right, on the Ethereum blockchain has to follow a certain interface, right? And that interface is called ERC, and a number is given to it, right? This number, the central authority to reviews and gives you that number, right? What does ERC stands for? Ethereum request for comment, okay? So ERC20, I'm specifically going to talk about this, is a very standard interface, right, to define tokens, right? Tokens which can be used as quote unquote coins on the Ethereum blockchain, okay? So I'm not going to talk in detail about it, right? I've just mentioned that what this contract looks like, right? So like just to quickly talk about total supply, as the like name specifies, if you want to look up the total supply of a coin, right, then you call this function, right? You want to know the balance of how much coins a particular owner owns, right? Then you call this balance of function, right? Allowance is really that, hey, how much like minting allowance. Actually, sorry, it's not like minting allowance. Sorry, I'm actually missing it. It's not on the top of my head over here. Transfer, pretty straightforward. You want to transfer coin from one address to another address, right? You want to approve a particular operation, right? Like let's say transfer. Transfer is an operation, right? It will require secondary approval. So approve is one, right? Similarly, transfer from inline to the transfer function, right? Which is more explicit, that from and to means that somebody invokes is on behalf, like the like caller is working on behalf of someone, right? So that's what the transfer form function is, right? So yeah, I mean, this is something fun, right? I mean, if you really want to become a Solidity programmer, you kind of like have to learn the concept of these ERC interfaces, right? I will leave this slide with one interesting thing. ERC 721. Remember this name. When we get to NFTs, I'm going to ask you guys that, hey, what was that ERC number I told you guys about? And we'll talk about it over there. Blockchain and its various applications. This is a slide I would actually stop. I think so. I need like about 15 minutes on this particular slide, but there's too much to like cover. But I'll try my best not to go in depth. Are you all with me on this?
I think so. If anyone has to leave, I mean, they can, because we are recording it in case they want to listen to it. So I think let's cover this much. I think we will probably have another session for sure, but I want to get maybe some of this stuff covered today.
Perfect. So blockchain, and again, sorry for like being a verbal slide. There was just so much which, I mean, I myself like put it over there so that I can even remember when I'm talking with you guys, right? So like blockchain has applications in many places. Okay, like if you wanna become an industry consultant and wanna go out there and say that, hey, instead of the central system, start using a decentralized system based on blockchain, right? There is a lot of thinking which goes behind it. Okay, and I want to kind of like educate you guys first of all that what does really where you can spot the application of a blockchain, right? First point, wherever you have too many intermediaries, right? I gave you an example of the whole supply chain use case, right, where manufactured in a factory in China, and by the time it comes to your Amazon warehouse, there are like 10 people involved, right? There are 10 people, like, I mean, that product exchanged through like 10 different hands. Okay, so clearly you can see that there are just too many intermediaries, right? And that means cost, right? The operation cost is huge. All those 10 people have to get paid, right? Maybe if you put a blockchain and a smart contract in between, it's one central contract defining all the rules and to-dos on that particular product moving from the factory to the warehouse, right? So you pretty much take away a lot of jobs as well, but fortunately or unfortunately, things are changing. All right, then separate or disconnected entities managing data for the same entity, right? And then the second point, information is so distributed that similar entities look pretty different, right? So the whole idea is that, again, going back to the product, right? That a product, right? Let's say it's a it's a tennis racket, right? Manufactured in a factory in China, right? By the time, right, you are registering it across all those 10 different systems, right? Somewhere in one system, it is just called a sporting good, right? And again, there are various other sporting goods. There are cricket bats, there are baseball ball like bats. I mean, there are soccer balls, right? There are various different sporting equipments. Not every sporting equipment may require a very careful handling, right? But this tennis racket being like built over here, right? It is super special. It requires careful handling, right? But by the time it gets to system 5, it says, hey, it's a sporting equipment. Now, sporting equipment have a pretty general handling protocol, and people who are looking at it, they will say, ah, just sporting equipments, handle them, the handle them just like, I mean, you don't have to handle them delicately. Okay, let's just say, I'm just going to throw an example, right? But that tennis racket requires delicate handling, right? So we got a problem, right? That the more people in between, right, they have switched the definition of something which required delicate handling to no delicate handling, right? So like that's a big problem, right? So again, I mean, wherever you spot systems like, I mean, like operations running this way, think about blockchain and smart contracts. That if I bring a solution which is blockchain enabled and a smart contract connecting all these 10 parties with one code base, right, with one place to like look up the status of anything which is started from the factory and going to the warehouse, right, then life will be so easy. Okay, but there are some really important questions which you should ask a business. Okay, and these are some of the like questions which I myself use in my daily work life, right, where I kind of like have a little bit of role where I'm sitting with various teams, and we are kind of like looking at that, hey, do you really need blockchain over here, right? So I watered down these questions to like look them to kind of like make them more like generic, right? What business problem are you trying to solve, and does it requires for a system to be distributed? Do you really need a distributed system? That's the like net ask in this particular question. You know, distributed systems are painful systems. Okay, they have various issues. I'm not going to get into the details of it, right? Maybe something you guys are going to learn over time your like self, right? Then similarly, we talked about the properties of blockchain, right? So we like talked about it, right? That always on, privacy, resistance to like censorship, right? You have complete data integrity, right? It's trustless, right? The zero downtime, right? These are the core characteristics of a blockchain, right? So going back to the questions that, hey, what is that one property you're looking for? Sometimes you can enable that property even in a central system, right? So you may not need a blockchain every time, right? Would your business be comfortable in sharing your data publicly, right? Remember, the data which you create, the beauty of blockchain is that anybody, anywhere can read your data. Going back to the example of where a volunteer is registering their activity on a central platform. What if today Naimbai is the only authorized user, right, to view the data? But what if there are 10 other people who are viewing the data? But the best part would be when they are viewing that data, the data is pseudonymized, means that it is just a big sequence of characters you will see, right? For like you, it will be junk data. But there are systems who can actually decipher the data, I mean, decrypt the data and figure out, oh, this is what it means. Okay, so like primarily these are nodes, right? That every node can actually read the real data if they want to. Okay, so is your business comfortable in doing that? So many businesses, especially the payment industry, they're very careful about blockchain, right? They like blockchain, they want to do things on blockchain, but at the same time they're super careful about it. Okay, then does your business require fast processing of transactions? The answer is most of the business, yes, right? So that's a pretty straightforward thing to ask, right? How many entities are involved in your business, right? Do you want to bring it down, right? So that's another question, right? Immutability. Once data created, do you want to allow data to be changed? 99% of the businesses come back and say, oh yeah, you know what, sometimes we do take action on the data, so we would like to like change it, right? We have a life cycle associated with that data. But then again, that's where you have to sit down and you have to explain them a little bit that what really immutability means over here, right? Immutability, we're just saying that once data is registered, you cannot go back and alter it. So this is one step. This point number 6, I spend a lot of time in my day job, right, explaining like various kind of like you can say groups within my organization that, hey, what does blockchain really gives you with that, right? And then similarly, would your business be comfortable with never being able to remove or edit past transactions? That pretty much goes in line with question number 6 and 7. The payment industry, the medical industry, right? They are very particular about it. Once data created, nobody should go back in there and change it, right? So but maybe some other industries would be okay with it, right? They may in fact want you to go back and change data, Okay, so I'm gonna so like I will say that these critical 7 questions. I would like you guys to keep them with you, right? That whenever you are thinking about blockchain, go ahead and try to answer these 7-8 questions and see that, hey, if the answer to 5 of them, right, I mean majority of them is yes, then you may need blockchain, right? Now which blockchain? Remember, it's not Bitcoin and Ethereum the only blockchains. There's so many other blockchains, right? Every blockchain is offering a different solution in a different industry for a different industry, right? I'm quickly going to talk about various applications, okay? And I want to talk about one of my favorite ones, right, which is personal identity security, okay? And I'm not gonna talk through rest of the like slide. I'm just gonna stop over there, right? Personal identity security. Let's talk about it, what it really means, okay? Um, um, your social security number, okay? Actually, that's not a good example, sorry. Let's just say your birth certificate, okay? Your birth certificate is a sensitive piece of information, right? Which you keep, right? When you, let's say, apply, right, for, oh man, sorry. So you know, take it back, rewind, right? Okay. I'll just stick to the home financing use case. Okay. Um, let's go back that you're trying to refinance your home, right? Or you're trying to buy a home, right? The first thing they ask you is that, hey, let's just see that, hey, you're going to apply for a loan, right? I mean, let me see that, hey, how financial worthy you are, right? So they're going to ask for quite a bit of sensitive information over there. They're going to ask for something called the W-2, right? A W-2 has all the information that, hey, how much money you made throughout the year, right? They're going to ask for, and W-2s are sensitive. It has your social security number on it. It has your full name, your date of birth, right? Your address, right? These are all sensitive bits of data, guys. Don't put them, be very careful when you put them around in forms, right? Be, like always look at where are you registering this data, okay? So this is a sensitive bit of data, right? Similarly, you put your, I mean, they ask for your pay stubs, right? They ask for your tax records. So all these documents are sensitive documents, right? Now, what do, right? They ask you for this data, you pack them up in an email sometimes, or they just direct you to some central portal and ask you to go and upload that data, right? Now, you don't know how that data is going to get used, right? You have no control after that, okay? So you have a problem. I mean, if you are worried about how your information is getting used, you are going to have a few sleepless nights after that, okay? So instead, what you do is, right, that what blockchain can enable you with is that you have a system, you have a smart contract on the blockchain, which says, hey, register all your sensitive data with this blockchain. Okay, that's the step number 1. Okay. So, and blockchain guarantees, right? I mean, this is, by the way, also like remember, there's a concept of public blockchains and there's a concept of private blockchains, right? So things like these would really be honored by a private blockchain. Okay. So you upload all of your sensitive documents, right, to this DApp, right, this like distributed app, right, which is built on top of a blockchain, right. This app, what it does is that it takes all your like data, right, converts it into a binary format and stores it on the blockchain, right, and it also maintains a more like human readable format, right. But all this data is now persisted on the blockchain. Okay? So that's step number 1. Step number 2 is that you go in there and say that, hey, I authorized only entity A to preview this data for X time. Okay. So that authorization for a very limited time is the key, right? That you have all of your sensitive data uploaded to the like blockchain. And now the other thing which you are saying is you are adding the authorization on top of it. So anybody who comes in and looks up your W-2 now, right? They can only look up your W-2 just for 30 minutes. That's it. This is all the time they need. And of course, your DApp is the like sensitive app, which would be the smart app which you can create, where you can say that, hey, nobody can take a snapshots, nobody can kind of like copy this like data, right? So I mean, some intelligence can be built over there. But in short, what has happened is that you uploaded all of your sensitive data to the blockchain. Now, anybody who wants access to your data has to, number one, connect to the blockchain, and number two, has to find their authorization. Who provides that authorization? You provide that authorization, that only you can look up my W-2s and my like paychecks and my tax records, right? So that's like amazing, right? That you added authorization on top of the data. Then the like same thing you can do for like other people, other actors who are interested in previewing your data. Okay, so like that's one interesting example, right? And again, I mean, you can take this, maybe the like bank wants to look at your like documentations, right? Later on, maybe the like city needs to look up your sensitive documentation for like something, right? So you can always keep on providing authorizations. Let's touch base on another example over here. Securing secure sharing of medical data, right? You know, sharing medical data is a very big business. Okay, so being like the like medical industry, right? The medicine industry itself is a pretty sensitive business, right? Just sharing that data between medical service providers is another big business. Okay, and it's a very critical one. Whosoever has a role in it has a very sensitive and critical role, right? Now today, let's say if you are if you have your medical insurance, let's say with the Dignity Health, right? I mean, that's one medical group. Okay, you go and visit your doctors over there, right? They kind of like take your x-rays, they build your whole medical profile, right? Tomorrow you start your like medical insurance provider changes, right? It becomes Kaiser, let's say, right? So when you go to a doctor in Kaiser, the doctor at Kaiser will be like, I have no clue of your medical history, man, right? So you got to bring it to me. So you're going to go to Dignity Health, and Dignity Health is going to print out all these things, right? Or like there are some online secure ways of providing that like data, right? They're going to hold you back. They're going to give you a big stack of document. You're going to take the document, present it to Kaiser. The doctor's going to review it for days and then put it in their own digital format or whatnot. Okay. So that's crazy. That's just like so primitive, honestly, right? I mean, comparing to like the way how we do things today. And I actually had a pretty recent first-hand experience of this thing there, where I literally had to take printed copies, right, to another medical service provider, and they would just review it, and then they will say, okay, fine, we're going to create digital copies of it, right? So clearly there is a big gap, right? So in the world of secure sharing of medical data, you have a blockchain solution in line to what I explained for the medical identity security, right? So, sorry, for the personal identity security, right? That all of your medical data can be uploaded to this private blockchain, right? And you, as the owner of that data, right? I mean, it is your health, it is your data, right? You authorize who can preview my data. Okay, so that's another pretty interesting use case. Cross-border payments, I'm not going to touch upon it. I think so.
I think that's probably enough for
Yeah.
today. Maybe, yeah. We can
Yeah.
start again next week. So you are okay with the next week also joining us?
Oh yes. I kind of like intentionally broke my whole presentation into another third phase, because with this whole concept now made, right, the whole ground is established, I want to quickly talk about cryptocurrencies, and maybe I'll take a little bit of time in talking about NFTs, non-fungible tokens.
Yeah, so I think there's a lot left to do. Like these NFTs and cryptocurrencies are very important. And I mean, if someone, maybe I'll also maybe give it a shot, but if we can also show maybe a 10-15 minute thing to show how to mine on these gaming computers, right? So we may not make much money, but we at least understand the process and how to do it, right? That's
Yeah.
something we also want to do as part of this exercise when we finish the blockchain.
Maybe let me think about it and talk to you offline on that.
Okay.
Right? I think, I mean, if the ultimate goal is to put something out there and see if it brings money, right? NFT would be the best way. But let me
Yeah.
think.
No. You are the expert. I think you will have to guide us on that. But it's not to make money, also to understand, because there is a lot of discussion. People hear a lot of mining and all that stuff. So I want these kids to have a feel of it, that what is it really like. So not from the purpose of making money, but mainly to understand how it is done.
Perfect. Yeah. We can definitely do something about it. Yeah.
There was one question in the chat. Let me just quickly see if the question is still. The question was, how would a smart contract look like for a digital transaction done on a website? I think you have gone over a bit on this. Asad, do you still have this question, or you are okay with that?
I think it's fine, yeah, because there are just different functions, like in the voter, if the voter is still able to vote, and but yeah, so just like different functions are going to occur for the transaction, right? But the overall structure is going to be the same, right?
So let's save this question for the next week. So
Okay.
how about that? We will probably go over this question again.
You know, there is actually a website. It's called Etherscan. Okay, so if you give me another few seconds, I can actually show you for how this thing looks. Where is the excuse me. So so your question is that how does a smart contract looks like when it's running on the Ethereum blockchain? I think that was your question, right?
Yeah.
So look, a smart contract looks like exactly the same as I showed you. Okay, nothing changes on like that. Okay, give me 1 second. Sorry. Yeah. So so it doesn't look any different, right? It is just your general code, right? You compile it into a binary version, right? And the EVM, which is called the Ethereum virtual machine, right? That just executes your code. Okay, just like how your like Java compiler or your Golang compiler works. Okay, but when your smart contract is running on Ethereum, right? I mean, on the blockchain, how do you trigger any operation on the like blockchain? You trigger that by looking at the address of the smart contract. Okay, so you can see something called to contract. Okay, so the smart contract gets this big giant address. That's it, right? Just like how you run your APIs, right, on your computer. If you're running locally, then you get local host and with a port, right? If you're running on a server, then you get an IP address, right? In the world of Ethereum, you get this big giant address which is pointing to your smart contract. Okay, so once you wrote your smart contract, compiled it, deployed it, the only thing you know is this address. Okay, then you post transactions to the smart contract, right? I mean, you like just like how you call your post APIs, right? And you pass a unit of work to your API to work on, right? So like similarly, you create your unit of work, right, on the caller side, right? You can see over here from, right? This from person, right, is also known by their wallet address on the blockchain. Okay, there's a concept of wallet, and every wallet has an address, right? So this person pretty much like creates this data, packs it into another binary, right, which is encrypted, and sends it to the smart contract. So so honestly, if you want to, again, I mean, I'm much more like
I don't think we want to go that deep.
Yeah, well, kind of like a geeky discussion on that, but I can talk to you about how this whole Etherscan website works. but feel free to go to etherscan.io and just click around, just see what is that, what is that. Many of it is not going to make sense, but honestly, the more time you spend on it, automatically you will start learning, okay, this is what it means.
Okay, all right. Jazakallah khair, Brother Basam. I think this is
Welcome.
great, that we have you cover this for these young kids, and it's I think great blessing for these guys that they are at this young age, they are learning all this stuff. They don't have to understand this 100%. Even if they, I feel even if they get an idea what the blockchain is, that still would be great, because they will be much better than or most of their peers, because they have no idea what blockchain is.
Exactly. You know, I will tell you about my journey. I have been trying to learn blockchain myself for the last 1.5 years. Like I at work, I actually have my calendar blocked daily for 2 hours, and the topic is steady. Okay, so I myself is learning every day. It is such a big, vast, and a I will say an overly complicated in kind of like domain that it will take a lot of time. So follow along, right? Pick up all these like keywords, right? See what is helpful, what is useful, but then take your time to like learn and adapt to these things.
All right. Thank you so much. Jazakallah khair. We will see you next time, inshallah. Allah
All right,
Hafiz.
inshallah. All right. Assalamu alaikum. Thank you.